great Tuesday. Happy Wednesday. Changes of state. What are we looking at in this picture? You can tell me what you think it is, or you can make an observation. Taylor, go ahead.
I think it is a flower, and it was a rain dropping down. Small rain dropping down.
Excellent. Okay, it's a flower. Maybe the water on there is from the rain. Anyone else have another idea? All right, well, it is a flower petal, and that water, we don't know what it's from. It could be from the rain. It could be from the morning getting warmer or colder, making condensation happen, right? Jack, please keep yourself muted, okay? Just because there's a bit of talking in the back. All right, so this is what we're going to learn about today. How are these little drops of water made so they can fall from the sky or other places? Today we will. Let's have our super happy and energetic Milk. Milk, go ahead and read. Super happy and energetic. Help us wake up.
Take homework. Very quickly learn about condensing gas into a liquid.
Can you say condensation? Very good. Okay, nice work. So, homework and condensation. A very simple day. First, quick review. Melting. Please read. Moon, go ahead and read the whole thing.
Melting is a change from a solid to a liquid. Some solids, such as gold and glass, will only melt when they are very hot. Other solids, such as ice and water, melt at much lower temperatures.
Excellent reading, Milk, and that was fast and happy. You and Moon, you and Milk did a very good job. Moon and Milk did a very good job. Okay, so I just want to make sure we all understand that matter melts at different temperatures. This is called the melting point. Remember, we looked up glass melts at 1,400 degrees Celsius. And chocolate melts at about 115 degrees Celsius. Degrees Celsius is how you say that. Everyone, please read this yellow writing. Actually, sorry, first I would like everyone to read just this first sentence. 1, 2,
Melting is changed from
Melting
solid
to a liquid.
Right. Excellent. A solid to a liquid. Now go ahead and read the writing in yellow.
Matter melts at different temperatures. This called a melting point. Glass melts at 100
Very good. I know degrees Celsius is very hard to say. Celsius. There's an L in there. Let's please have Banana. Would you like to read this for me, Banana? You did a great job yesterday. Oh, he just walked away from his computer. All right, let's hear from Blue Moon. Blue Moon, go ahead and read about evaporate.
Evaporate means to change from liquid to gas and go into the air.
Excellent. From a liquid to a gas. Just like in this picture, this pool is very hot. It is called A hot spring. It's made when the Earth's surface is very close to magma, to lava underneath the ground. When Earth's surface is very close to the magma, it makes the water on Earth's surface hot. And then we get a hot spring. And since the water is hot, it evaporates quicker than cold water. It will lose water as gas very quickly. Okay, and who remembers what word is inside evaporate? Rosie?
Vapor.
Vapor. Like water vapor. Vapor is another word for gas. Okay? So, if you're having trouble remembering condensation and evaporation, which one is a liquid to a gas? Remember, evaporate has the word vapor in the word. It means it turns into a vapor, into water vapor, okay? So, one more time, everyone unmute and say evaporate.
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 Excellent job. Okay, now that we've done that quick review, homework check. So, first one is Cherry. Excellent day. I can't speak. Excellent job. She put out a candle, a cup, and some toys. Cherry, could you please read what you wrote for us?
Hello everyone, my name is Cherry. Today we will see how things change. We have a candle and an ice cup and a toy. Let's see how they can change. When we add heat,
Let's see how they can change when we add heat, right? That's how you're changing it when you put it by the windowsill.
now I see the candle. It's melting at the bottom. The ice cube is melting in the water, but the toys are still there. Bye.
Excellent, wonderful, Cherry. And I love how you told it as a story, like what was happening each step. This is great. So the candle melted a little bit. The ice cubes melted all the way into a liquid. All right, but the toy is still there. That's great job, very great job. All right, and this one I really liked because Bunny put the times. As a scientist, it's important to know, well, how long did that take? So she did a spoon, orange, and ice, and she measured it at 2 different times. Very, very good. Okay, so Bunny, what happened to the water over time? I see the ice melted, but what happened to the water over that long amount of time?
It was not cold as before.
Say one more time, sorry.
It is not cold as before.
It's not as tall as before. Why do you think that is, Bunny? Why do you think your water was not as tall as it was before?
No, it is not cold as before.
Oh, not as cold as before. Okay, I see. Not as cold as before. All right, let's take a look. Here's Jack. Jack did hot water, seasoning, ice, and an apple. Oh, I love the picture, Jack. And here it is a while later. Oh, very interesting. Jack, could you explain to us some of the changes that we see here? Go ahead, Jack.
The hot water condensation.
Condensation.
And I don't know how to spell the next.
The Italian seasoning, not changed, okay?
Yes.
Jack, how do you know that the hot water had condensation happen? How do you know that there was condensation? What did you do to find that out?
Because I use one
Lid.
materials to put it in the top.
Yes, to put on top. We would call that a lid. So you put a plastic lid on top.
Yes.
And what told you that there was condensation? What did you see?
What?
How do you know there's condensation? What happened to the lid?
The lid has water and air.
Excellent. So who can tell me, how did the water get there on the lid? Did the water jump up onto the lid? How did the water get up onto the lid? Ben 10?
Water vapor is rising up, but the lid is closed, so the water vapor can't rise up.
Excellent. Great job, Ben 10. The water was turning into water vapor. So actually, Jack saw two things here. The first thing would have been evaporation. The water was turning into water vapor. Then the lid stopped the water vapor. The water vapor cooled down, less heat, and made condensation. It turned back into a liquid on the lid instead of down here. Evaporation, cool down, and condensation, back to a liquid on the lid. That was a great example, Jack. Okay, let's quickly just look at a few more, but pretty much done. Hot ice, hot water. Up here, this is Moon. Moon mentioned that the hot water was evaporating to the sky. Excellent. And the ice was melting. Very good. Great, and there were quite a few things that had no change at all. Puppy, very cool pictures. Oh, this one was butter. Excellent. Puppy, which one has the lower melting point? And the butter melting point would be higher. Maybe butter needs more heat because look, the butter is not melted all the way yet. Maybe the butter needs 30 degrees Celsius. It has a higher melting point. Okay, ice, 0 degrees Celsius, it'll freeze. Above 0 degrees Celsius, it'll melt. Butter, I'm just guessing, maybe around 35 degrees Celsius, it will melt. Chocolate will melt at 115 degrees Celsius. So, ice, lowest melting point, it will melt first. And chocolate, highest melting point, it will melt last. This one needs the most heat, chocolate. That's why the chocolate got soft but did not melt. All right. Very interesting, Puppy. Thank you for sharing that one. Very good. Here we see a lot of condensation on the outside of the cup. That's because when the warm air all around the cup touches the cold cup, the water in the air turns to liquid. Water in the air turns to liquid on the outside of the cup because the cup is cold. It turns the water in the air into a liquid because the cup is cold. Has anyone seen this before? I'm sure, have you guys ever picked up, I have condensation on the bottom of my drink. because this cup is colder than the air. So when the water vapor in the air touches it, it turns into a liquid. Has anyone picked up a really wet cup before?
No.
You picked your cup outside and it's wet? Yeah.
Yes. It is so
Sophia,
wet.
does that water on your cup, does that come from inside the cup? What do you think? Did this water vapor come from inside my coffee?
I think it is outside the cup.
Excellent, outside the cup. Remember, there's water vapor all around you. Okay, changes of state. Let's continue. Last class, we talked about how does heating change matter? Who can tell me? How can heating, adding heat, making it hotter, how can heating change matter? Who can tell me? Who can tell me? Hands up. Only one person can tell me how adding heat can change matter. Ray, go ahead and tell me one way.
Make water evaporate.
Excellent. When we add heat, liquid water can evaporate. Excellent, excellent job. Okay, what's another one? There's another way that heat can change matter. Taylor?
Heating can change something to another kind of matter or their properties.
Can you give me an example? Oh, to another type of matter. You're talking about chemical change. Yes, burning.
And another properties.
Excellent. And it changes the properties. Exactly. Very good. Heating can change matter. The first way is liquid water can evaporate into a gas. The second way is chemical change. Changes the type of matter and its properties. What's the third way that heat can change matter? We have liquid to a gas. What are we missing? Think about your chocolate, your ice. Sino, what's the other way that heat can change matter? Not sure? Susu, can you help? Excellent. So, 3 ways that heat can change matter. Now we're going to learn how cooling can change matter. Cooling, less heat. Less heat. Everyone, go ahead and read the title. 1, 2, 3.
How
can
So, how can cooling change matter? Okay, can I please have the first sentence read by Nam, can you please read the first sentence? Banana, please do not request my screen. Okay, go ahead, Nam.
Matter can also change by cooling or taking away heat.
Can you say taking?
Taking.
Very good. So matter can also change by cooling or taking away heat. I would like everyone to read the next 2 sentences. Everyone, ready? 1, 2, 3.
Gases when they are cold. Gases mean to change a gas to a liquid.
Excellent. Now I just want one person to read it so we can really, really listen and be ready to answer my questions about it, everybody. Okay? Let's please have Sam. Sam, go ahead and read this for us.
Read what?
Gases, the same thing we just read as a class.
Gases condense when they are cooled. Condense means to change from a gas to a liquid.
Excellent. So everyone look at this picture in the background. This is a window. Inside it's cold and outside it's hot. What happens when the hot air touches the cold window and cools down? This is a really hard question. I'll give 1 point on Class Dojo if someone can answer. What happens when the hot air outside touches the cold window? Rosie.
When the hot air outside touches the cold window, it will change to water.
Excellent. So will it change to water as a gas or water as a liquid?
Water as a liquid.
Excellent, Rosie. 1 point on Class Dojo for Rosie. Amazing. The gas, the water vapor outside will touch the cold window and change into a liquid. Everyone, please underline the sentence that says the cause for condensation. What makes condensation happen? Why does the gas turn into a liquid? Underline the word that says why the gas turns into a liquid. Taylor and Puppy, first two. Excellent. Sophia, good. Bunny, our girls are on it today. Boys, where are you? There we go. Milk, thank you. By cooling or taking away. Excellent. Okay. How does cooling affect liquids? So we just talked about how cooling can affect a gas. What happens when you cool down a liquid? You all know the answer to this. Susu, go ahead, Susu.
They change into a solid.
Excellent. Wow, Susu, amazing. When we cool down a liquid, it freezes into a solid. Like when we cool down liquid water, it turns into solid ice. How does cooling affect gases? How does cooling affect gases? Pasta, how does cooling affect gases?
Cooling make gases into liquid.
Excellent. So cooling, gas to liquid, liquid to solid. Condensation, freezing. Banana, can you please read the first sentence? About water vapor condenses. Go ahead, Banana.
Water vapor in the air condenses when it touches cool objects.
Excellent. Can you say condenses?
Condenses.
Very good. So Banana, what does that mean? Water vapor is a gas. When it touches a cold object, what happens? What does that mean that it condenses? Do you know, Banana?
Liquid.
Excellent. When the water vapor gas touches a cold object, it condenses. It turns into a liquid. Nice work, Banana. This is why you see small drops of water on the outside of a cold glass. Where else have you seen condensation? There's a lot of places. For example, on my coffee can. Where else have you seen condensation? Sam?
The bathroom.
In the bathroom, on the mirror, when you take a shower. Zook?
In the window.
On a window, excellent. Pasta?
In my room.
In your room, excellent. What about the one up in the sky? What does condensation make in the sky when water cools down high in the sky, what happens, Ray?
Lên story 4 chưa? Đây chú chơi rồi
A
đấy.
rain. Yes, everyone. Rain is condensation. The gas goes high into the air and it gets cold and then it rains. Nice work, Ray. Here, condensation. We can see it right here. Everybody, please, actually, let's have Blue Moon. Can you please read this one under the water bottle? Blue Moon, read under the water bottle. All right, Ben 10. Ben 10, please read under the water bottle.
Water vapor condenses on the outside of the bottle.
Good. Condenses. The water vapor condenses on the outside of the bottle into a liquid. And Milk, can you please read the caption under the window?
Like what that has condensed on a
Say
window.
water that has condensed.
Water that has condensed on a window come with air inside the room.
Excellent. So it's really cold outside. Maybe it's winter. It's cold outside, but it's hot inside. So when the air inside touches the window, it condenses. Let's have first two sentences. Nam. Nam, can you please read the first two sentences?
When liquid cool, we can freeze. All because of that wax and some other liquid will freeze at
Room temperature. Very good. So this wax is frozen. It's not in the freezer, but things like wax will freeze at room temperature. They freeze naturally. It doesn't have to go in the freezer. Other liquids such as water need to be much colder to freeze. Okay, so look here. Can you think of any other liquid that becomes a solid at room temperature? What about melted chocolate? Will it freeze at room temperature and become a solid?
Yeah.
Yes.
But what is room temperature?
Room temperature is about 25 degrees Celsius. Any other ones? Anyone else have an idea? Moon, anything? Okay, Sophia, go ahead, Sophia.
butter.
Butter, excellent. Butter will become solid again at room temperature. Any others? All right, here are the ones I came up with. Chocolate, melted metal, and lava will all become solid, will all freeze at room temperature. Okay. Now, just quickly some grammar. Verb. The verb condense, to condense. For example, the gas condenses into liquid. This is a verb. The gas condenses into liquid. Condensation is the noun. The gas condenses and makes. Condensation on the glass. So everyone say verb condense.
Verb.
Condense.
Good. Now please read the sentence. Go ahead and read the sentence. 1, 2, 3.
So gas
condenses
into
liquid.
liquid.
Again, but look, condenses. We have another ES. Condenses. 1, 2, 3.
Condenses.
Everyone, condenses.
Condenses.
All right, now please say noun, condensation.
Noun.
Condensation.
All right, and go ahead and read the sentence. Everyone, I'm watching your videos. 1, 2, 3.
gas condensation.
Gas condense and make
And make condensation.
All right, very good, but I still heard some people just say condense. The gas condenses. There's another S. The gas condenses and makes condensation and makes condensation on the glass. Who thinks they can read that sentence perfectly? Who thinks they can read that sentence perfectly? Zook, go ahead, Zook.
The gas condenses and makes condensation on the glass.
Excellent, wonderful job, Zook. Okay, and one more time, everyone say verb, evaporate.
Verb.
Evaporate.
Verb. Evaporate.
Verb. Evaporate.
All right, now please read this sentence. The water evaporates into a gas. Go ahead.
The water evaporates.
Excellent. Now say noun, evaporation.
Now
Evaporation. The water
Gas.
Excellent job. Any questions about which one's a verb and which one's a noun? Just remember noun has ation. Condensation is when things condense. Evaporation is when they evaporate. Any questions? All right, we'll do this little activity tomorrow. Tomorrow and Thursday and Friday will just be review. So it'll mostly just be games and questions and quizzes and all of that stuff. Everyone, go ahead and unmute and read what we learned today. Everyone, go ahead. Excellent. Very good. So your homework is a quizzes. This is important. You must take it until you get at least an 80%.